Okay, so so let's start with computing limits lah. All right. So let's start with the most basic ones, and then we will work our way through to the hardest one that I could find. So let's go here. Mm, practice. I think it's practice. Yeah, rather just practice. All right. So before I start, do you guys rather are me doing like in the background will be black, then my pants will be white, or the other way around? Which one do you guys prefer? Because I'm afraid that maybe you guys have some issues with your eyesight whenever you want to read my writing.
This one is fine for me.
Yeah, I like the first one.
All right. So let's start with. So I'll be writing it down, so you guys don't have to like go through the book, but I'll write down the functions. Okay. So let's start with the simplest ones, where we don't need to be worried about the undefined, indeterminate forms, so on. All we have to do is just substitute the limits. But truth to be told, that these limits will not be asked, lah, but I'll be giving you such an idea first. Okay. So let's say they give us a limit where x approaches to -3 for x squared minus 13. Now, this is a very elementary question because all we have to do is just substitute into our polynomial or function here, where since this function is continuous at every point, it's a parabola, so there is no discontinuity, then obviously the limit exists for all x's in the real domain. So just substitute and you will get a really straightforward answer, which is -4. So that's about it. So let's move on to not much more difficult, but the same thing, but involves rational functions, where we have a limit where y is approaching 2, that we have y plus 2 over y squared plus 5y plus 6. From here, all we have to do is just substitute again. I think it will not give us the indeterminate form. So 2 plus 2 over 2 squared plus 5 times 2 plus 6, you will get 4 over 20. You will get 1 over 5. So that should be the answer lah, when you simplify it. Okay. So how about functions where you really have a power? The power is not an integer lah, it's a rational power. So let's say we have question 19. Okay, I'm gonna write down the questions number. So this should be question 11, and this one should be question 18. So how about question 19? So question 19 gives us limit as y approaches to -3. Then we have 5 minus y to the power 4 over 3. So from here, all you have to do is just substitute it as usual. Nothing too much to be fit of. And then 8 to the power 4 over 3, we know this should be 16, where 8, the cube root of 8 is 2, and 2 to the power 4 is 16. So that should be the answer. All right. So that is one of the most elementary questions that they could ask. Hopefully, but 100%, I am really confident that they will not ask this type of questions. But it's good for practice, okay, to get used to computing limits. But how about what if, let's say for question 22, what if they ask us for limit where h approaches 0, square root of 5h plus 4 minus 2 divided by h? How about this limit? Now, this limit is just the next level of limits where we have, if we direct substitute, then we will get square root of 4 minus 2 over h. H should be 0. And from here, you could see that is the denominator is undefined. We can't divide something with 0. But for the numerator, is 0 divided by 0. So this is what we call as indeterminate form. Okay. So how do we solve this kind of form? So if you recall, I think last time I sent you the notes on how to do it. But from here, all you have to do is really simple. There are a few ways. We factor it, we rationalize it, and I think there is another way. I'm not sure. Okay, but for this one, limit as h approaches 0, square root of 5h plus 4 minus 2 over h. All you have to do is just multiply by 1. Where doctor taught us, well, professor taught us that we multiply by 1, but we multiply that is similar to this lah. So multiply by 1 means that we are multiplying by square root of 5h plus 4. Basically, we are multiplying its conjugate lah. So for square root of 5h plus 4 plus 2 divided by square root of 5h plus 4 plus 2. So from here, you could, expand it. Then based on this factor, let's say a square minus b square, we can factorize this to become a minus b, a plus b. By following it, you will get limit as h approaches 0. Okay, let's say this term here is our a, and this term here is our b. Same goes to other terms. The 2 is b, and then the square root of h plus 4 is a. So if we compare it to the right side here, a squared minus b squared is equal to a minus b, a plus b, then we should get 5h plus 4 minus 4 divided by h square root of 5h plus 4 plus 2. And then for our numerator, we could simplify it. The limit where h approaches 0, 5h over h multiplied by square root of 5h plus 4 plus 2. Then from here, you could simplify it since our numerator and our denominator has a common factor. And then from here, then you can direct substitute into this function. So you will get 5h will be 5 multiplied by 0 plus 4 plus 2, and then you will get 5 over 4. Okay, just like that. So here are one of the examples where directly substitute will not get you the right answer for the limit. Okay, so you have to factorize it or rationalize it or multiply it by its conjugate. Then you will get the answer, right? Hopefully there are no issues regarding of it. Okay. So any questions so far for question 22? Can we move on?
No, I'm good.
All right, good to hear. How about Putri? I think just not far, right? How about Putri? Is it okay? Hopefully it's okay. All right. So let me continue on with the next question. For limits for quotients. Okay, now here we will be computing limits where it involves quotients. Okay, so let me give you a really simple one where it involves factoring. Where limit as x approaches 5, x minus 5 over x squared minus 25. Okay, so on the spot, as you can see, if we directly substitute the value 5 into our function here, we will get the indeterminate form, yes? So we know that x squared minus 25 can be factored, right? Since 25 is a perfect square, which is 5 squared. So limit as x approaches 5, x minus 5 divided by x squared minus 5 squared. So we could factorize x squared minus 5 squared to become x plus 5x minus 5 based on the formula here, x a squared minus b squared. Then we could simplify this and then directly substitute to get 1 over 10. So this part, not too difficult, okay? Hopefully you guys could handle it. If not, then you could ask lah. But how about, okay, I think so far, okay, let me give you another one, which is question, okay, let me give you 2 more. One is where we only have to factor either numerator or the denominator. So for question 26, we have to x approaches 2, x squared minus 7x plus 10 over x minus 2. So from here, x squared minus 7x plus 10 over x minus 2. So obviously, when you directly substitute, you will get the indeterminate form. So you have to factor out the quadratic function or the parabola for our numerator. So what is our factor? Now, it should be, wait, let me do it. Let me do it manually. So 2x minus 5x plus 10 over x minus 2, limit as x approaches 2. And then from here, we should get x minus 5, x minus 2. And this should be our answer. So x minus 2, you could simplify it, and then -3 by directly substitute. So hopefully you guys have no issues with this kind of questions. So let's go on with this question. So given here, it's a bit different, not too different to the point where you can't recognize it, but we have a function where x to the power of -1 minus 1 over x minus 1. So I think there are a few ways, but the way, one of the ways where I could think of it right now is where limit as x approaches 1 over x minus 1. Let's make it our rational function, x minus 1. Now from here, let's combine these two terms into a single term. Okay, so it should be limit as x approaches 1, where 1 over x, 1 minus x over x divided by x minus 1. So, but from here, we could make these two terms similar, right? By either factoring negative out one out of the other, whether you want to factor the negative here or from this term here, okay? So let's say I want to factor out 1 minus x, the negative 1. I want to factor out -1. So it should be x approaching 1, where -1 over x minus 1 divided by x minus 1. From here, we could see that our numerator and our denominator has this common factor. So we could simplify it, and then we could directly substitute to get -1. That should be the answer for this limit. Okay, any questions so far? Hopefully you guys are okay with this type of questions. How about you guys? If there's no questions, then we could move on to our next question for limits.
Okay.
Okay, all right. So far, so good. All right, so let's continue on with this kind of question. So 32, we have limit as x approaches 0, 1 over x minus 1 plus 1 over x plus 1 divided by x. Obviously, when you directly substitute x into this function here, you will get the indeterminate form as usual. So what are we going to do? Now, there are many ways, but I would like to give you one of the most simplest ways to do it, where all you have to do is just combine these two terms into a single term as usual, that I showed you before. So how do we do it? By multiply both sides. So for our first term, I'll be multiplying it by x plus 1. And for my second term here, I'll be multiplying it by x minus 1. Okay, they divided by x as usual. So since we have the common term for our denominator here, we could make it as our single term. So limit as x approaches 0, we will get x plus 1 plus x minus 1 divided by x minus 1, x plus 1. So in our numerator here, x plus 1 plus x minus 1, we can simplify as usual. Limit x approaches 0 to x, because 1 minus 1 is 0, divided by x minus 1, x plus 1. We could simplify it to get 2 over x minus 1, x plus 1. Then you could just directly substitute the value 0 to get 0 minus 1, 0 plus 1. You should get -2. So that is our answer for the limit. Okay. So for these questions, honestly, I usually approach it by making it as a single term for my numerator and my denominator, making it sure. Okay. So hopefully this part you guys are good. Okay, so now question 33. Now question 33 gives us a limit where, I'm sorry, u approaches 1. U to the power 4 minus 1 divided by u to the power 3 minus 1. So there are, I mean, there's a way where if I want to do it, wait, I want to try it though. I never tried this before. So I'll be using the long division where u to the power 4 minus 1 divided by u to the power 3 minus 1 because I'll be applying the limit laws later. So this should be u. This should be minus u to the power 4 minus u. This should be negative 1 plus u. Okay. So we could apply it. Then we should get limit as u approaches 1, u plus u minus 1 over u cubed over 1. So I use long division to separate it. So my quotient and my remainder. All right. So now why did I do that? Because I don't want to trouble myself factoring u to the power 4 minus 1. Even though we could do that easily, but I think this is much more the safer route. Well, so we know. Okay, I have class. It's too noisy, Kyra. Guys, is it noisy? The background? Can you hear anything?
No, it's not that noisy. It's okay.
It's noisy. Okay. Sorry, my little sister wants to interrupt me. Here, let me. Okay, that. Okay. So, oh no, wait. I need to close something. I'm very sorry. It's a really busy day in my house. Okay. All right. So for question 33, okay, u to the power 3 minus 1 can be factorized. I think if I recall back, it should be like this. If I go here, if I write this down, a to the power 3 minus b to the power 3 is equal to a minus b, a square, I think it's minus ab plus b square. I'm not very sure. Let me check again. Factoring. Yeah, okay. Yes, correct. So here is the formula that we'll be using to factor out our u cubed minus 1. So from here, limit as u approaches 1, u plus u minus 1. By comparing it, u is a while 1 is b, where 1 is equivalent to 1 to the power 3. 1 to the power 3, so it's the same thing. Therefore, by applying the formula that I highlighted, it should be u minus 1, u square minus u plus 1. Okay, so we could simplify because our denominator has a common factor. So now I think that all we have to do is just substitute the u value to 1 plus 1 over. Or basically, I'm not saying that. I'm just saying that as u approaches 1, and then for each term, okay, let me give you a proper explanation. I'm not saying that we directly substitute because that is for if f1 and then 1 plus 1 over 1 square minus 1 plus 1, etc. And that is I directly substitute. But what I mean is that as u approaches 1, obviously the first term u also approaches 1. And how about 1 over u square minus u plus 1? It will approaches 2. I think as u approaches 1, u approaches 1, so that term will be approaching to 1 as well. Okay, so that's basically what I'm trying to say. I'm not saying that we directly substitute, but in a sense where we are substituting it, okay? So 1 plus 1 over 1 square minus 1 plus 1. So from here, we know that 1 minus 1 is 0, and then 0 plus 1 is 1. So 1 plus 1, and then it should be 2. Okay, that is our final answer. Okay, the limit itself is 2. All right. So any questions so far about this part here? I mean the long division. Hopefully you guys are recognized the long division method in basic maths. So it's good practice if you want to do, or if you guys know how to factor u to power 4 minus 1, then go ahead. By all means, you can do it. That's if you want. If you don't remember how to use long division, okay. So hopefully there is no issues of it. So let's continue on. All right, now let's deal with a question where it involves square roots, or in other words, sets. But I don't use sets often. I use the term like square root or cube root because, as you can see, square root of 2 and cube root of 2, both of them are sets. But if I want to differentiate them, I should be more specific by saying square root of 2 and cube root of 2 and so on. Okay. So question 35, they give us the limit where x approaches 9 for square root of x minus 3 divided by x minus 9. I think our last session, if I recall, I did show you this, but since I'm recording, then it would be very beneficial to the viewers. So there are two ways. First, I factor my term x minus 9. So how do I do that? So I know for a fact, right, where square root of x times square root of x is equivalent to square root of x squared, where a is equivalent to x. Okay, but ignoring the absolute function, okay, I'm just using this properties. So as I know, x could be a perfect square where it's the square of x square. Okay. So from here, limit as x approaches 9, square root of x minus 3, we'll get square root of x plus 3. 9 is a perfect square as well. Square root of x minus 3. So from here, you could simplify it since it has a common factor, and then directly substitute into this function here. You should get 1 over 6 as your final answer. Or there is another way where you compute it like this. Limit x approaches 9, where you multiply by the denominator's conjugate. So square root of x minus 3 times with square root of x plus 3 divided by x minus 9 square root of x plus 3. And then you know that square root of x minus 3 multiplied with square root of x plus 3, you should get x minus 9 over x minus 9 multiplied with square root of x plus 3. Simplify it, you will get 1 over 6 as well. So both of these ways are acceptable. Okay, no problem. Okay, so the final question where is about conjugates and everything is this question. So let me give you the final one, and then we will be answering trick questions. Okay, trigonometry questions, hopefully, but I'll be finding more lah. Yeah. Space Jam, where is the Space Jam? Okay, sandwich. Sorry, because sometimes there are other books where it says that they use squeeze theorem. Okay, so right. So they give us limit as x approaches 4. X approaches 4 where 4 minus x over 5 minus square root of x squared plus 9. Obviously, if you directly substitute, you'll get the indeterminate form. So how do we solve this? Well, for me, I'll multiply it by this denominator's conjugate. So multiply by 5 plus square root of x squared plus 9 divided by 5 plus square root of x squared plus 9. So from here, you will get limit where x approaches 4, 4 minus x, 5 plus square root of x squared plus 9 divided by 25. As usual, I just showed you just now what happens if you multiply by its conjugate. You will get x squared minus 9. Okay, I'm just skipping a few steps, honestly. But it should be x squared plus 9, but it has brackets lah. But I expand my value -1 so that it will become minus x squared minus 9. So from here, limit as x approaches 4, we will get 4 minus x as usual, 5 plus square root of x squared plus 9, then divided by negative x squared. I think it's plus 16. So honestly, if I rearrange this, it would be 16 minus x squared. So we know that 16 is a perfect square, x squared is also a perfect square. Then you could factor it to become like this. X approaches 4, where 4 minus x, 5 plus square root of x squared plus 9. And then our denominator here will be 4 minus x, 4 plus x. Simplify it, direct substitute. You will get, I think, 4 plus square root of 25 divided by 4 plus 4. It will be 10 divided by 8. It will be 5/4. So that should be your answer. Okay. If I'm a bit too fast, right, with my explanations, do let me know. I'll take it slow next time around. But yeah, it's just a similar question, and this is a really good practice if you still aren't used to limits. Okay. So far so good. Any questions that you would like to ask before I continue on with limits with trigonometric functions?
Wait, is it 5/4 or 5/8?
5 plus 5 is 10. 10 divided by 8. So I simplified to become 5/4.
I didn't see that.
Right. Okay, so that is enough for the usual limits. Now we are going to sorry, I'm eating. Okay. So that is for limits. The ones where we are used to it, I think, for our pre-university studies. Okay, we are familiar with it. So now let's start with limits with trigonometric functions. Now in this section here, I think it's, well, directly, it's a direct question. Yeah, it is direct. So I want to show only just one question. Okay. Yeah, only one question because no, I think this limit is really too elementary, but I mean, I'm gonna try the last question, which is question 50. But in the next section, I think it's 2.4, 2.5. We will be going through more, okay, where it's in approaching infinity, asymptote, etc., and so on. Okay, for now, let's just try and compute this limit. So this limit is really direct, honestly. So 7 plus secant square x. We know secant x means 1 over cosine x. So we could convert it to become in that form. So from here, I think I'm going to make it bigger a bit. 1 plus cos square of x. And then just direct substitute. 7 plus 1 over cos square x should be 1. And then you'll get square root of 8, where in other words, you'll get 2 square root of 2. Okay. So that's basically about it for trigonometry functions in this section. But later we'll be going through with much more difficult ones. Okay, what is this? Oh yeah, so let's try and let's solve this kind of questions. It will be very interesting. So question 55. Now we are computing limits in this fashion. So we are given two limits where limit x approaches to b, and then f of x goes to 7, and this one will be limit as x approaches b for g of x, where is equal to -3. So this question is just trying to test us on our limit laws. Okay. So for our first one, limit as x approaches b for f of x plus g of x, where we only expand the limit to become limit based on the limit law. Limit x approaches b f of x plus limit x approaches b g of x. So we know the given information is similar to our question here. So all you have to do is just directly substitute. So 7 minus 3, you will get 4. Okay, same goes to question B, where we multiply two limits, f of x multiply with g of x. So as usual, limit x approaches b f of x times with limit x approaches b g of x. There we will get obviously 7 times negative 3, it will be negative 1. Okay, the question C, they give us a constant in front of our function x approaches b 4 times with g of x. You could bring it outside like this, and then we could just directly substitute as well, so negative 12. And then for the final one is for the, if you divide both functions, so limit as x approaches b f of x divided by g of x. They're based on the laws given. We know that limit as x approaches b f of x divided by limit as x approaches b g of x. Then from here, you could solve it as usual, negative 7 over 3. Hopefully there is no issues regarding of it. I'm going to wait for the given x. All right, so I think that's okay. Complete, but if you want to compute limits, wait, because of their connection, wait, because I'll, yeah, wait, before I go to the next section, hopefully you guys are really, you guys know how to do this, because this is not something that it should be asked, but maybe it would be asked. Any questions? I don't know, who knows? All right, so limits of average rate of change. So yeah, guys, if you guys want to find the tangent, right, then you use the definition of the derivative. I think the limit where h approaches 0, f of x plus h minus f of x divided by h. I think you guys have no issues because it's really similar to our previous questions on how to solve it. If we can't solve it directly, if it gives us the indeterminate form, then refer back to the notes that I gave you last time for solving it. Okay, so I don't think that we should do that. Okay, now for sandwich theorem, okay, this will be interesting enough because this is a bit new, right? Because in our pre-university studies, we didn't discuss about the theorem. I think for metrics, yeah, I'm really confident metrics students will not be familiarized with the theorem. But based on the theorem itself, let's say we have h of x. Then we have f of x between h of x and g of x. So I think, right, if limit, let's say it approaches to a certain value, and we have L, and the same goes to gx, it approaches to a certain value, and it gives us the similar value as h of x, then in conclusion, where limit h approaches c for f of x should give us the same value, which is L as well. So that is the, in the nutshell of the theorem. It's my informal explanation. But if you really want to get into it, then you should reread the theorem itself. But this is the nutshell. Okay, so let's solve one of the questions. Okay, let's solve a really, it's not a hard one, but it gives us the idea of the theorem itself. So they gave us, question 63, they give us square root of 5 minus 2x squared. It's between f of x, f of x is between square root of 5 minus 2x squared and square root of 5 minus x squared, where the values of x is between -1 and is between 1 in exclusive. Okay, so find limit where x approaches 0 for f of x. Okay, no problem. We could do that. So limit as x approaches 0. Let's find for square root of 5 minus 2x squared and square root of 5 minus x squared. 5 minus 2x squared. Only because this is, you could directly substitute because it will not give us the indeterminate form, etc. So you will get 5 minus 2 times 0 to the power 2. You will get square root of 5. Same goes to where x approaches 0 for square root of 5 minus x squared. This also gives us the value of 5. Okay. So based on the theorem itself, as the limit as x approaches f of x, we should get square root of 5 as well. So that is our final answer. Okay. Hopefully there is no issues to solve this limit by using sandwich theorem. Okay, any questions so far?
I just want to ask, if we choose other than 0, still get the same, right? Like if we choose 1 or
No, I don't think so. It will not. It only works for if x approaches 0.
I
Yeah.
see.
Yeah.
So like for these kind of questions, it's like best to put x coming like closing into 0.
Yeah.
Like, okay. Alright.
Yeah. It's based on a question like as x approaches 0. In the theorem says that it will, the both of the functions will squeeze it out. That to the point where the limit itself will be equal to f of x. Is that it's between them. Yeah. So it should be equal. Yeah.
Alright. Okay.
But if I go back to the actual explanation, because what I explain is in a nutshell. So sandwich theorem, but I can't find it. Huh. There. 2.2. Where am I? This is 2. This is 2.4. Okay. Yeah, but guys, can we like extend our session because I really do want to besides 2.2, I would like to answer one-sided limits and then asymptotes if I can. Or if you guys have other things to do after this, then let me know so that I will not take your time away. So all right. So up here, the sandwich theorem. Yeah.
Actually, I'm going somewhere at 10, but then I can still join. I can still join now because I can join in the car. But then can you give me like a 10 minutes break for me to like get into the car? Is that fine?
It's okay. It's okay. So, all right. If that's the case, then I would say I'll create 2 parts lah. So, in the near future, okay, I think like this week I'll be okay. Later on, we will discuss on when are you guys free for this week. Okay, then we could continue on with part 2 of computing limits. How's that sound?
But I'm fine for today actually because later the place I'm going to is I'm gonna like sit and then study there. So macam boleh je today kalau nak buat juga.
I see, but it's okay lah. I think that we want to study effectively, right? So I think that we should do it later for the next.
Alright.
Yeah. But wait, let me. Okay, no problem. But thank you for letting me know. So based on the theorem itself, it says suppose that g of x is less than or equal to f of x less than or equal to h of x, meaning that f of x is between gx and hx for 2 functions. For all x in some open interval, okay, except possibly at x is equal to c itself. Suppose also that, okay, x approaches c. Okay, so meaning that if it satisfies, if x approaches c for g of x is equal to h of x, where x approaches c to h of x, then if that satisfies that condition, then it should be where x approaches c f of x, that it should give us the same value for the limit. It should give us as long as it satisfies the conditions. So yeah, just look back at the previous theorem and see that if it works. Okay, that answers the question. Okay, So let's do, I think we could do two more. I have one question for the past year. I did one. I think, yeah, I want to show you guys the questions lah. I think it will be very good exposure on, I give you guys the idea of what our questions will be, okay? 2 minus x squared is g of x is between 2 minus x squared and is between 2 cosine x. So from here, obviously apply the theorem. Okay, let's see what happens if you apply the theorem. So limit x approaches 0, 2 minus x squared. Okay, before, oh, I forgot, the question wants us to find when x approaches 0 for g of x. Okay, so this, nothing new, just directly substitute. Same goes to 2 cosine of x, directly substitute as well, 10.2. So since both of these limits are equal, therefore, based on the theorem, it should give us the same value for g of x, where it should be 2 as well. Okay. So that is about it for the squeeze theorem. Comment, hold, where does for x close to 0. Okay, I'll show you later. All right, so let's go and check out the past year questions where I really do want to show you guys the past year question. So where is it? I did last time. I don't know where I put it. Wait. Oh no, I showed my personal information. Okay, I'll edit the video later lah. Damn it. That is unfortunate for me. Okay, I am so sorry. Yeah, bahasa Quran, mana matematik. Ni. So I tried to this one. Here we go. So these are the, well, this is the past year question for 2016. And let me do something first. Wondershare. Do I have Wondershare? Oh, I do. Okay, that's good to know. So yeah, this is the few questions. So for question 1, nothing special of it. All we have to do is just factor x squared plus x minus 12. For question 2, you have to simplify it first. Okay. So for question 2, let me show you how I did. So I simplify it to make it in this form, and then I just compute the limit, right? I just compute the limit itself. So wait, let me see here. Oh yeah, that should be answer. But the thing about this part is question 4, where they ask us about the ceiling function. So I haven't answered because I haven't studied much about it, but later on in our next session, I might show it to you guys. And then for question 3, is the identity. Okay, so let me show you my working for question 3. It's just this. So we have limit x approaches 0 from the right. So it doesn't matter right or left, it's still approaching 0, right? But from the right, of course. So from here, I applied the identity. Yeah, I applied the identity where I think it's limit as x approaches 0 for sine of x over x, it should give us 1. And this is the same case for x approaches 0 for x divided by sine x is equal to 1 as well. Okay, no problem. So from here, I use the product rule for limit laws. Yeah, based on limit laws, I use the product rule by expanding it to become in this form. And then I expand my limit for each term, and then I solve it from there, and I got the value of -3. Okay, so that is how I solve it. So hopefully you guys are familiar with the identity. Okay, hopefully you guys are really familiar with it because it's really useful. And then for question 4, 5, wait, 1, 2, 3, 4, 5. For question 5, I think I solve it like this. Yeah, I convert my tangent to become sine of x, Then I expand it, and then from there I could simplify it. And then, as usual, I applied the limit identity for x approaching 0 for x over by sine of x, and solve it from there. Okay, so it's very, very, very crucial for you guys to know the identity. And I think I haven't done for question 6. Sorry, Kyra, bising. Sikit lagi, sikit lagi. I'm almost finished. All right, let us try for x minus modulus of x. Okay, let's try that question. I haven't tried it, honestly. Limit as x approaches 0 from the right, I think. 0 from the right. No, from the left, sorry. From approaching from the left. Where x minus modulus of x, or sorry. Sometimes I got mixed up with modulus of absolute function. Usually modulus is for like complex numbers, then we'll call it modulus. But I think for now, I would call it absolute functions, because the definition of absolute function is basically giving any value of x will always give us an output of 1. So how do we solve this? So first, I create a piecewise function for my modulus of x here. So it should be x where x is larger than 0 and negative x where x is less than 0. So from here, I know that this symbol means that it is approaching from the left. So this fits for this function right here. For x is less than 0, okay? Because it means that it is approaching from the left. If I graphed it out, it should be like this. So this means this direction down here, it means that it is approaching from the left. So I'll be using the function which is negative of x to substitute. So limit as x approaches 0 from the left, x minus negative of x over x, then this should be 2x over x, and finally we can simplify this to become 2, and we know where limit as x approaches c, let's say x approaches c, and the a is a constant, then the value of the limit is a as well. Nothing changed. So finally, the answer should be 2. Okay. So that is the past year questions for limits. I mean, I haven't gone through all of them. I've only gone through for 2016. I don't know the recent syllabus, but yeah, this is very useful if you want to see how far or how strong your knowledge of limits is. And yeah, unrelated note, here are a few questions. Okay, let me show you. So here's like the simple format of it. They will give us the, like for chapter 1, and then we have the intermediate value theorem stated. Yeah, we have to state what is the intermediate value theorem, what's it used for. Then we have to show blah, blah, blah. All these are okay so far. And then here, continuity. Selanja means continuity, okay? Continuous, sorry. Okay, here, and for derivatives, yes. You want a brush? Do I have? Oh, I'm sorry, I don't have a brush. It's in the store. Later, nanti kita tengok, okay? All right, so then integration, Rolle's theorem. Remember about Rolle's theorem? Where if f of a and f of b is equivalent, then f prime of c is equal to 0, right? And then, yes, the equation has precisely one solution. Here are the, computing integration, and that is basically it. Yes, it's a lot of computing, but I'm not saying that since there is a lot of computing questions, you guys should just leave the theorems, okay? No, please do at least have a small book for theorems and definitions, because in later on when we learn a higher level of mathematics, we will be relying on those definitions, okay? So that is all for now. Any questions that you guys would like to ask? How about Farah? How about Prithvi? Hopefully you guys have a really solid idea of how our exam will look like.
Yeah, I think so far okay lah. But I do maybe like you're planning to do part 2, right? Like this coming week.
Yeah.
I kind of want to like also focus. Is it okay if I want to understand epsilon, that kind that part?
Sure, sure. All right then.
Yeah, I think in 2.3, right, the precise definition limit, something to do with epsilon and then the inequality. And I don't get that part well.
Okay, so let me give you a bit of an introduction for just 1 minute. So I asked the professor last time on how am I going to show that the limit exists by using the precise definition. There are 4 keywords. First is let, given, oops, given, suppose, and then finally is suppose, let, given, suppose, and then check. So let me give you a simple one, which limit as x approaches 2 for x plus 5 equals to 7. So I want to prove it, right? That this limit exists. Okay, but this is for linear lah. So linear is really, really straightforward. So let my epsilon be bigger than 0. Okay, that's the first step. Let my epsilon be bigger than 0. And then given delta, because based on the definition, says that for all epsilon bigger than 0, there exists delta. Okay, there exists means that at least one. So we have to find at least one value of delta which satisfies this. And then suppose from here, suppose that x minus 2 is less than delta, if I'm not mistaken, or 0 is between. Sorry, 0 is between this. Yes. Oh. No. Okay, check again. Check is from here f of x minus L. Okay, where f of x is our function, so x plus 5 and our L is 7. And then it should be x minus 2. Then from here we know that x minus 2 is less, the absolute function of x minus 2 is less than delta. So from here write down less than delta. Then delta is equivalent to epsilon. Yes. Yes, it is. Here is the fundamentals of what are we going to prove. Okay, so here are the 4 important keywords lah. But I have notes where me and my friend discuss about it, which is really useful. So maybe let's create 2 sessions. Maybe one is for computing and one is for precise definition. Okay. How's that sound?
Yeah, sounds okay. Sounds good.
All right. Okay. All right. So Patri, hopefully you understood on how to compute limits. And I think Farah is already got the idea of how to compute limits. Hopefully.
Yes, it was clear.
All right. So the viewers from home, thank you so much. So I'll be stop the recording.